party techniques that allow a collection of validators to jointly perform requests, or in particular, write requests across these ecosystems. And finally, the layer is programmable. So you can actually have, it exposes very simple APIs and function calls to make this interoperability a lot more accessible and user-friendly for both application developers as well as users. All right, so let's take a deeper look at the technical stack. And let me go from the bottom to the top, just to explain it. So first of all, there is a validator set. And a validator set also consists of various components which are composable in various ways. So there is basic kind of validation of the consensus that the validator does. There is a broadcaster process that's needed to actually propagate messages through the consensus by the validator. There are various multi-party cryptographic processes like multisigs or threshold crypto. And then there are connections to various external chains. So as a validator, you may opt in to vote on some events from Bitcoin or Ethereum and kind of contribute to finalization of requests coming in from those chains. So uniting all of these validators is a Tendermint consensus. So that's what's actually used to propagate messages and deliver it from one validator to the other. And on top of it sits an application layer protocol that we expose to make connections simple, right? So, and I'll go through some of these requests in a little bit, but on a high level, you can think of it, well, if you want to set up a connection to yet another EVM chain, there's like 4 or 5 commands that you can execute, and the connection is there, right? So you don't have to kind of build your own bridges or like roll out any complicated tech along the way. It should be as simple as possible. All right. So what are the core network functions that AXELAR network executes? So one, it records information about external gateways, right? So as I mentioned, on each bridge and chain, there's a gateway contract, you can think of it. And we need to understand what the address of it. And so that's fundamental to any interoperability network. So two, we're managing various kind of keys and validator sets of this external gateway. So you can rotate it, you can swap one for the other, and so on and so forth. And finally, we are authorizing various read and write requests. Okay, so any kind of interoperability network has to have 2 basic operations. You want to read stuff and you want to write things. Okay, so you always have to think who is reading and who is writing, and you have to have those operations in place. All right, so now let me go through very 2 simple flows that you can build using the AXELAR network. So one is just setting up a connection from the network to an external EVM-based chain. And 2, I'll talk a little bit about this chain-agnostic routing feature that we built into the network. All right. So how do you make a connection to a new chain? So it's actually one command to start. So first, you have to generate a version of a threshold key for that chain. Okay, and so you can run a command on the AXELAR network. You can say, I want to generate a key, and in this case, it's going to be a key for the Ethereum chain. And so what happens under the hood is that a collection of validators perform a multi-party cryptographic protocol to generate this key. Okay, so you can use like a multisig version, or you can use like threshold version. And the key is established in such a way that only the validators know the corresponding shares of this key, right? So no single validator owns it. The whole network collectively is then going to be responsible for managing operations over this key. So second thing you need to do, you need to deploy a gateway, right? So a gateway is this kind of object that can support read and write requests. And it's a couple of commands that you have to do. So you call AXELAR-D deploy gateway. You specify what is the gateway that you want, or you can push in your own gateway. In order to actually deploy it, you need to sign it with the key that you previously generated. Right? So you can call a sign command. All the validators perform, again, multi-party protocol. The gateway is signed. And then anybody can actually take it and post it on the chain that you're trying to connect. Right? So it doesn't have to be the validators themselves. So third thing you want to do, and this is actually an application, more like an application layer protocol, is you can deploy various contracts to the gateways. So for instance, if you want to transfer tokens from a chain A to a chain B, you need to deploy a token contract. Right? So in this example, we are deploying a token contract for a Bitcoin. and we're deploying it on the Ethereum network, right? So it's a command that you just run and say, OK, here's the token contract, which is an application layer protocol, deploy it, and it gets plugged in into the gateway. And from that moment on, you can sort of transfer this asset to the chain. And the final command that the network supports is to verify various cross-chain requests, right? So again, these gateways are responsible for monitor and read and write requests. And when there is a read request, such that you need to transfer some amount to a destination chain, you need to verify it. So you can actually call a command and ask the network to verify this request, and the validators are doing kind of all the complicated operations to make this happen. So this is like as simple as I think it gets in order to set up a connection to an external chain and start processing requests. So you don't have to roll out anything complicated from that. All right, and the second feature that I'll just mention is what we'll call sort of a cross-ecosystem routing layer. So what is the basic idea? Suppose you're actually building an application, and in this case, like on a Cosmos ecosystem or a Cosmos-based chain, and you want to allow users to deposit and withdraw directly into the application. Okay? So one thing you can do as an application builder is you can just issue a request to the AXELAR network and ask it to generate a special link account for you to a specific destination chain. Okay? So for instance, you call a command and you say, I want to transfer from Osmosis to an Ethereum, and I want to allow my users to withdraw to a specific Ethereum destination address. Okay? From that moment on, AXELAR can generate a special address for you that knows the request that you're trying to do, and it knows that you're trying to allow the user to withdraw all the way from your application front end their tokens to a specific Ethereum destination address. And then you can use IBC to just tell the users to deposit into the specific address that AXELAR network generated, right? And then that's it. You call it a day, and then so AXELAR network from that moment on is going to take the request, understand that it needs to go to Ethereum as an example. It's going to process, it's going to finalize, sign the transactions, pay the gas fees, and so on and so forth. And your user never has to think about those kind of a bridging or moving their assets explicitly. Okay, so this is you can integrate directly into the application and make it a lot easier for the users to deposit or withdraw assets. All right, so what are we trying to build here with the AXELAR network? We're effectively trying to build a framework or a platform to make interoperability as easy as possible for three types of players. So one is for blockchain builders. We want to build a kind of a set of bridging mechanisms that is secure by design. So you're not adding any trust assumptions in the process, and you can use just a handful of commands to integrate new chains with minimal effort. So second, we want to build a platform that is designed for the application builders. So if I'm an application builder, I always will have a need to have interoperability process various application layer protocols for me. So you can customize your protocols, you can deploy your own protocols either around token transfer or more general smart contracts, and right away leverage the platform to get many-to-many connectivity, right? So not just from one chain to another, but from one to many. But finally, what we're really trying to do here is to solve a problem for the end user at the end of the day, right? We want to make it as easy as possible for the end user to just take their assets, deploy them in applications across different ecosystems without having to go through bridging technologies or understand, any commands that they have to interact with along the way. But to get there, there are various layers that we have to fill in, okay, that currently don't exist in the stack, and we're kind of working on to fill in them in. So finally, I think I'll just mention that whenever we talk about interoperability, it's not a destination. Okay, so if you look at the networking stack today, it's not one protocol. Okay, it's a collection of protocols that have been built over the years, everything from the routing to transmission layer protocols to application layer protocols and APIs on top of it. Okay, so today we are still at this bottom layer. We're still building this fundamental connections and interoperability system to talk to one another. But I think as you also got a sense from the IBC panel earlier today, the next thing will be building more application layer protocols and actually making it easy for the users to interact across all of these ecosystems, which today is still a nightmare. So, yep, happy to answer any questions and talk about this more. And we are continuing to grow the platform and the team. So come talk to me if you're interested to learn more. Thank you.